Yeah, we do.
Well,
Good idea, Lucas.
Okay, so if you have powers with the same base, okay, and we were to expand this, the whole goal of these rules is you don't have to expand them. So this would be a times a, and that would be 4a's, right?
Yeah.
Okay, so together,
Why wouldn't it be 6a?
it would be a to the 6th.
Oh, okay.
Okay, without, so coming up with a rule. So if you guys make a nuisance of yourself, then I will just record a different time.
Oh. No, but that was an actual question.
Yes. So this is a to the 6th. So the rule is, so we don't have to do this because they don't intend for you to list out every base and count them all up. Okay, and I'll show you why in a minute. The rule is, rather than doing all of this, you add the exponents if the bases are the same.
So you only add the exponents, not the bases?
No, the bases do not change.
Would it matter if we capitalize
No.
Oh, you should make a bloopers video of it. Where you just get everyone to yell as loud as they can and be like, this is what happened.
I'm pretty sure it's just meant to be called.
We all get kicked out.
Okay, so even if one of or both of your exponents are negative, doesn't matter. The rule is you keep the base the same and you add the exponents. So this would be a to the 6th plus -3, or you can just figure it's 6 minus 3, which would be a to the 3rd.
Yeah. This is
All right.
really easy.
This is pretty easy. Where it gets a little bit more involved is when you have more than one base that, you have bases that are the same and then one or two that are not the same and number bases. Yep. So, for instance,
Can you look down, please? Or up? Thank you.
all right. So with something like this, because multiplication is commutative, means you can reorder, you can group however you want to, we would change the order and say this is no different than 2 times 3 times n to the 5th times n to the -2. So you'd put the like bases together. Now, these are not like bases, but you can multiply 2 times 3. If they had exponents, you would evaluate them separately with their exponents before you multiply them, okay, if the bases aren't the same. So this would just be 6, and then you'd apply that rule to those. So that would be n to the 3rd.
That's so really easy.
All right.
Just explain that.
Brackets?
Yeah, that was just bump, point, bump.
All right, so when you have more than one expression, then we group the things that are alike. So this would be 5 times 2 times 3. And then you have a couple x's. Times x to the 8th times y to the 4th. So all we're doing here is grouping, because they're all part of the same product anyways. So 5 times 2 times 3 would be what? 30. X times x to the 8th. Be careful with this. X to the 9th. Quite often people will go, well, that's x to the 8th. Well, if that x didn't count, it wouldn't be there, right?
Right.
That's actually a 1. That's an exponent. So you would add 1 plus 8 to get x to the 9th. And then you only have the y term, so that would be your answer.
This is literally all A3 is.
Pretty much. Now you have to keep in mind, say you do that, you multiply what you need to multiply, and then you have a negative exponent left over, or a 0 exponent left over. You still have to take care of that as well. The rules you've already learned don't disappear because we're in a different section. We're adding on to the rules that you've already learned, okay? So now, in addition to taking care of 0 exponents and taking care of negative exponents, you're now learning how to multiply bases that are the same, what to do with their exponents. So we have now 3 rules, okay? Lucas.
So how do you get the x to the 9?
Okay, because this is actually x to the first. Okay, and when you add 1 and 8, now that's what I was saying, is that x wouldn't be there if it didn't matter. There'd be no purpose for having it if it didn't count. And it doesn't count as 1 because that's not a 0, right?
Yeah.
So you have to count it as another x, all right? Okay, so let's look at another.
Can we do a negative problem?
So m squared times n to the negative 2 times 7m.
Would you do the simplifying, not simplifying, but getting rid of the negative first?
You could. I mean, if you want to group them together, if you want to get rid of the negative, yes.
Do you just always add like the variables, or do you also do like the number, like the 7m? Do you do 7m plus m squared?
Okay, we're not adding. This is multiplication.
Times.
Yeah. Now, there's no other coefficients. These, if you wanted to put coefficients there, they'd be 1. So multiplying times 1 isn't going to change the 7. So if we regroup, that might be your best bet for starters. Put the m's together. So we have 7 m squared m and n to the negative 2. Okay? And at this point, if you think you're going to be one that is going to forget about that exponent of 1, I would pop that on there so you don't forget. Now this, well, we're going to combine these. So this would be 7m to the third. Now, if you still want to put the n to the negative 2 and deal with it in the next step, you can, but knowing that that is negative, that's going to have to go down, right? So it's going to be over n squared. Yeah. Don't try and do too much all in one step. The more involved these get, they're going to be a few steps. This section isn't so bad, but once we start adding more rules on, there will be people who try and do everything in the first step, and it's too much, okay? This, you can kind of say, okay, I can handle a couple things in one step, so that would be simplified. Let's try another. N squared times n to the third times 7n.
Yay, negatives.
Wait, are there negatives in there? Or no? Okay. I couldn't tell whether the exponents were negative or not.
No negative exponents.
Okay.
We'll add one more on for fun. So throw that on the end.
So,
Now, one of the things you should be noticing is you have a base of 7. You've got a negative, which is like a -1 in front. and all the rest are n's. Yeah.
I think I remember learning last year, you add the exponents when you times the bases.
Right.
Okay.
Yep. Okay, so that negative is going to go way out in front. That has no power on it, right?
Yeah.
Okay, that's like a -1. So we're going to throw that in front. We're going to put the 7 in front with it because you want to gather your number bases in the front.
Can we scratch off the 0 right there?
Yep, you can get rid of that. So it's up to you at this point if you want to just add up what you've got or if you want to group them. I'll group them, so if you look back at these, remember that's a 1 on this guy right here. Okay, so I have -7
6.
n to the 6th.
Easy enough.
All right, we're going to stop there. There is an application to scientific notation, but it's pretty easy. So we'll do that tomorrow.
Is that all?
Yep.